Hey guys, today we're going to program on implementation of single linked list. So the objective is to implement the following operation in a single linked list. Insertion operation at the front of the list, at the back of the list and at any position in the list. Deletion of an element from the list, then displaying all the elements in the list. So yeah, I've done the program, so see this. So you can see that header file, there are two header files in this program. One is the IO stream, and next is the CST DL. And as we are using namespace std for the normal standard to get the final content and the output. So yeah, in the structure, we are giving a struct as node for the each element. The element we are calling node. So in each and every node, we are having two things. One is the data and the reference. One is the data and the reference to which it points to the next node. The whereas the rear, the last, uh, the bottom node will be referred to as the reference code will be null, and uh, and yeah. So we are giving a node star length and star head equal to null. So void in front. This is for the insertion at the front. So we are giving a new node and we are entering the data in that. Say in new node then data. So in this new node we are giving the elements as null, and if the head is equal to null then the head will be the new node, because if nothing is there in the head, then the head will be what the element which is inserted to it. So the new node, it will be linked to the head, and the head will become new node. So that's what insertion in the front. Whereas the insertion in last. So this is also we are entering the data to insert in the end, and we're giving a data for that. And in this, we are giving a uh, temporary node type. So like in this temp equal to head. So if the head equal to null, and again we're keeping that there is, so we're putting head equal to the new node. So if it is while we are giving a while loop for the statement, so the temp link is not equal to null, then the temp equal to the temp link. So the temp link will be the new node. So the temp link will be the new node. And the next we are doing is to delete it. So if head equal to null, then we are checking this if statement, so that if the list is empty, we are returning it. Otherwise, we are giving the number, entering the element which will be deleted. So yeah, the deleted element is head data, where head will become, then head will become null. Or else again we're giving a while loop for this. um, while loop to for the temporary, if it is not equal to null, then the previous temp will be uh, temp equal to the temp loop. So the deleted element will be the temporary data. So it will be, so the element which we are giving will be deleted. And next thing we're doing is to display the element in an order of an insertion, of how we are inserting the element. So for giving node star temp to the head, we're checking if it is the list is empty or not, and we're giving a return statement. So like, and if it is not empty, then the viewer, it will display whatever elements are present inside the insertion inside the list. So the while statement will be like temp, or if while or if temporary is not equal to null, then the here will be the temp data, and it will point to the next node. The reference will point to the next node, and that's how it shows display. And this is void insertion at position. So in this thing, it has the data and also the position where it has to insert. So yeah, in this again we're giving a structure type. two things, a pointer and a yeah, and a template to create the node. So node entering the data, and the next thing you're doing is to enter the position in which it will be inserted. So the S equal to the head, and while S is not equal to null, then S equal to S, it will be linked to this arrow link. So counter plus plus, and you're showing the counter. So if the position equal to 1, then if giving an if statement of if it is equal to null, then we are showing the temporary variable. Or else the pointer will point to the it will be the head, and the head will be the temp, and the head of arrow link equal to pointer. So they're giving an again else statement if it is greater than 1 or if it is less than or equal to the counter. Then s is equal to 8, then we're giving a for loop for I equal to 1, I less than pos, I plus plus. We are incrementing each and every time till it comes to the position of where we have to insert. And pointer is equal to the s, and s equal to s arrow length. And pointer arrow length equal to the temp, and temp arrow length equal to f. And if it is out of the range, then again we're giving an else statement for that. See your position out of range. And this is to void search. So this for int value and full, and we're again giving a question. So we're giving bulls bull variable for this. If it is the full flag, if it is equal to false, then the list checking if it is head equal to null and if it is empty or not. And we are entering the value to be searched. Struct node and s is equal to that, implementing the position each and every time. And if the data, if it finds the value, then it is true and it shows the element, and shows also the position of the element. If it is false, then it shows that the element and shows the value of the element, and it shows that it is not found in the position. And we are giving a main function for that to enter the position, insert in front deletion display, search and everything. Switch case so like this you can see in front, with pop to delete to display to search to insert position to insert in the last. And the thing we are exiting. Let's run the program actually. So first let's see of insert in front. So first one, so enter the data, let's put 2, and again let's say insert again put 3, and yeah, let's display this. As you can see, 2 and 3 are inserted in a linked list. And as you also can see, the first head it is the when it enters, it goes like this. So like this becomes null, and again the rank becomes 142. And input next to be let's try insert at any position. Also. Insert the data to enter the data to insert 4. Enter the 4. Position will be the second. Let's display it. As you can see, the fourth it is inserted at the second. And then let's try to delete it. And we'll put deleted item as 2. Okay. So now let's display it. As you can see, the 2 is deleted and 4 becomes. Yeah. And now let's search. Enter the value to be search 3. The element 3 is found at position 1. So yeah, thanks for watching this implementation of Single.